All right, let's look at day 7 of your AP multiple choice questions without calculators. A sample of methanol, and here's our balanced chemical equation up here, is placed in a previously evacuated vessel with a pressure of P1. So that is our initial conditions, P1, and 600 K. What is the final pressure in the vessel after the reaction is complete and the contents of the vessel are returned to 600? All right, so what I'm going to do is I'm going to use the combined gas law to do this one. P1V1 over N1T1 is equal to P2V2 over N2T2. Now, it's a rigid vessel, so this is constant. My temperature is the same, so that's going to be the same on both sides. So let's pull out what we have here. Now, when we look at the number of moles or the number of particles, how are they different? I've got 1 particle here and 3 particles here. So I basically have P1 over 1 is equal to P2 over 3. So what I'm going to do, if I want to know the final pressure, that's P2. So P2 is equal to P1 times 3, which is answer choice D. All right, day 8. Here's a balanced chemical equation. It says a student adds 30 milliliters of HCl to this much iron, and a reaction occurs. When the reaction is complete at these conditions, which of the following is true? So we've got 2 that are talking about excess and moles, so we're just going to have to sort all that out first. So basically, I'm going to do my HCl first. I'm going to put that over here. How much HCl do I have? Well, I've got 30 milliliters, and 1,000 milliliters is 1.0 mole. So that is equal to 0.030 mole. Now, if you want to do this, you're going to have to, this is easy because it's times 1. It's basically 30 divided by 1,000, that's the problem. Remember that you can always use scientific notation. This is what we do in APES a lot. It's 10 to the 3. Remember, when you divide scientific notation, I divide this into this, which is equal to 3. I bring this over, it's 1 minus 3. 3 times 10 to the minus 2, which is 0.030 moles. When I multiply scientific notation, I multiply my coefficients and add my exponents. When I divide my coefficients and I subtract the denominator from the numerator, 1 minus 3. Really easy way to tuck those zeros away. All right, so that means that I have 0.030 moles of HCl. Now, let's look at the amount of iron I have. So iron is 0.56 grams. If I look on my periodic table, I know that my atomic mass is 56, which gives me 0.01 moles, sorry. So this is 0.01. All right. Now, which one is in excess? So when I have this much and it reacts, basically I need 2 times this much to go here. So I need, I'll put this in pink, I need 0.02 mole. So I have 0.01 in excess. If I need 2 times this amount, 2 times 1 to give me that. And when I do that, I get 1 to 1, I get 0.01 moles of that. So my HCl is in excess. All right. However, it says if it's in excess, 0.030 minus 0.020 is 0.010 excess, not that. So that crosses that out. HCl is in excess, and that remains. No, it's this, so that is out as well. 0.015 mole of this has been produced. Nope, we said 0.01, not 015. What about this one? Okay, so let's do this. We know this is very important. That's STP. You should always watch for that, because if you are at STP, then you know that 1 mole is 22.4 liters of a gas at STP. So that means that 0.01 mole would be 0.22 liters, and so D would be correct.